Alright, so today I am gone for a basketball game in Houston, so I'm going to make a few videos for you here for you guys to watch, and then I'll have some practice for you guys to do. Afterwards, we're about to start a new unit today on these things called matrices. So my goal of today is to kind of define what a matrix is. Some of you might have seen this at some point. I'm kind of doubting not. So we will get into a few complicated things over the course of this unit. I hope today is not too complicated, but I want to kind of define what matrices are. And then teach you guys how to do some basic operations with them, and then like I said, I'll have some practice for you after. We will have a couple quizzes over this before spring break. I won't be able to finish this unit though, so we'll actually have a test over this after we get back from spring break. We'll do a couple other things, then we'll review and we'll take the test. Okay, so let's jump right into it. By the way, if you're curious about the dates on those quizzes, that is up on campus, so feel free to take a look at that there. So we'll call today 7.1, and my main things I want to do today are adding, subtracting, and multiplying matrices. Okay, so I'm going to break this up into at least two videos. I'm going to go ahead and start out in this first one with adding and subtracting because it's super simple. Then I will do multiplication in the next one. So first of all, let me define a few things about matrices. So a matrix in and of itself is sorry, I want to make sure I have a good definition. So it's a rectangular array of real numbers. And that sounds really confusing. All an array is in math is just a collection of rows and columns that contains some sort of objects, in this case numbers. So let me give you an example. So an example of a matrix might look something like this. Across the top here we could have something like 2, 5, 4, -3, and then in our second row we might have something like 10, 6, 3, 2, and then in our last row we might have something like 5, 4, 3, and 2. Okay, so this is an example of a matrix. A couple things to keep in mind on a matrix: rows go across. Okay, columns go down. Okay, so as we see here, this one has 3 rows because it has 3 different pieces that are going across, and then this one has 4 columns because it has 4 different columns of information going down. Okay, we would say that this matrix right here, whenever we're writing the dimensions of a matrix, we always do rows by columns. Okay, so this is a 3 by 4 matrix because it has 3 rows and 4 columns. Okay. Last little thing here, when you are defining an entry of a matrix, okay, the way that we write this is A sub I J, where I denotes the row and J denotes the column. So for example, if I was wondering on this one, like what is I, let's go 3, 2. What this means is we want the entry that's in the 3rd row in the 2nd column. So if we go 1, 2, 3 rows, 2nd column, we would see that's a 4. Okay, if I ask something like what's A sub 2, 4, that means what's what entry is in the 2nd row in the 4th column. If I come over here, I see that that's a 2. All right, so there's just some very, very basic things about a matrix. Last little definition: if you see a matrix that looks like this, maybe like 3, 2, 5, 4, this is a 2 by 2 matrix. Anytime that the rows and columns are the same, we call this a square matrix. So you could have a 2 by 2, you could have a 3 by 3, you could have a 4 by 4, and so on and so forth. Sometimes it's easier to do things if the matrix is a square matrix, and so that's why I just want to go ahead and note that for you right now. Again, if it has the same number of rows and columns, it's called a square matrix. Okay, so let's go ahead and let's jump into a little bit. Let's start out with the easy stuff: adding and subtracting. So first and foremost, I'll say this: in order to add and subtract, whatever matrices you're adding and subtracting, they have to have the same dimensions. Okay, so they must have the same dimensions. Alright, so it's fairly easy to do this. Let's go ahead and let's try. Let's come up with two matrices to do this with. So let's say the first one, let's go 2, 1, 5, let's go 3, -2, 7. We'll call that matrix A, and then for matrix B, let's go 3, 6, 9, and then on the bottom here, let's go 3, -6, -12. Okay, so if I'm looking at these two matrices, this has 2 rows and 3 columns. So this is a 2 by 3 matrix. This is also a 2 by 3 matrix. Because they have the same dimensions, I can go ahead and I can add and subtract them. So, for example, if I wanted to do matrix A plus matrix B, all I would do is I would add the corresponding entries. So super simple. Row 1, column 1 in matrix A, I would add with row 1, column 1 in matrix B. So 2 plus 3 is 5, 1 plus 6 is 7, 5 plus 9 is 14, 3 plus 3 is 6, -2 plus -6 is -8, and 7 plus -12 is -5. And as you can see, the reason why I wouldn't be able to do this if the dimensions were different is because eventually I would run out of corresponding entries. Therefore, I wouldn't be able to do it. So they have to have the same dimensions in order for me to do this. You could also subtract them as well. Same idea, just subtract across the top, or subtract corresponding entries. So 2 minus 3 is -1, 1 minus 6 is -5, 5 minus 9 is -4, 3 minus 3 is 0, -2 minus -6, be careful here, that becomes -2 plus 6, that would be 4, and 7 minus -12, I'll end up adding those and I'll get 19. Okay, so there's the general gist of adding and subtracting. Again, fairly simple. It does get a little bit more complicated when we get to multiplying, which we will do in the next video. One other thing to note for this particular video, we can also do something called scalar multiplication. When you're working with matrices, and again, all this stuff that I'm talking about now is going to come back into play at some point in the unit, which is why we're trying to get some of the basics down right now. So let me display to you real quick what scalar multiplication is. So all that means is we're going to we're multiplying a matrix by a constant. Okay, so for example, if we define matrix A to be something like, let's go 5, 2, 3, 7, and 8, 4. We'll go call it 8, -4. Okay. There's no particular dimensions that a matrix needs to be in order for me to be able to do scalar multiplication. But I will go ahead and note this is a 3 by 2 matrix because it has 3 rows and 2 columns. So let's say, for example, we were going to do something like 5A. Well, all that means is we're going to take matrix A and we're going to multiply it by 5. So let me go ahead, just for the visual purposes, so I can write this down one more time and you can see it. We're just going to take 5 and we're going to multiply each entry in the matrix by 5. So that will become 25, 10, 15, 35, 40, and -20. Okay. So anytime we're doing scalar multiplication, it means we can just multiply all of the entries in the matrix by that particular number. Okay. That gets some of the basics out of the way. We'll do multiplication in the next video.